For that, I just make a small PPT. I'll go through with that. Just give me a second. Just give me a second. My screen is visible. Just
Yes, sir.
anyone. Okay, fine. So you can see this. I'll just go through this the uh, variety of ways to do the MATLAB programming. The first is .m, means only the code is there, and it is very difficult to model the power electronics or non-linear type of thing, as I already said, right? But you can make your figure or graph according to your choice. That is the beauty of this. The second thing is .mdl. It is very easy for any complicated system, but at the same time you cannot edit the figure, you cannot change the parameter. However, the this upcoming versions of MATLAB, they give the features to edit the figures as well nowadays, right? Now the next type of programming is just that is the mixture of these two. Means you can have the .m programming along with the Simulink. The Simulink file extension is .mdl, whereas the simple code-based programming extension is .m. Right. So what we do, we make the parameter in .m file, right? And for editing figure, we will take the data of that figure in the workspace, and from there we take that data in MATLAB to draw the plot and all, right? And this I have already show you the various block set of the Simlink. So I am skipping, and this sim power system is the main concentration of for our interest toolbox, which I have already explained you. All these window I have already shown you. When you open this, you can have the command history window and the workspace and all those things. And when you click this block, you will have this Simlink library. All this I have already shown you in the previous lecture, right? So this you can see from there, all element as function demos and everything I have shown you in our previous lecture. Now we will do some .m based exercise, and also we will do this problem here, that is the series parallel RLC network. When we are talking, we will solve with this network using the .m file as well as the Simlink model file. I'll just demonstrate this to you and also show you in the MATLAB. These are the various type. The case 1 only MATLAB, case 2 MATLAB plus Simulink using as function, and third is the MATLAB plus Simulink without using the as function, and the last that is MATLAB and Simulink. I'll show you how long code you have to written to execute this simple program. This is one page, this is second page. So you have to write these much line to get the result. What result? And this is for plotting the graph. This is for plotting the graph. So 3 page, after writing 3 page code, you will get this result, that is the voltage across the capacitor, current I2 and the I1. What are the I2 and I1? I2 and I1 are the these current. Let me show you the circuit. This I1, this I2, and the voltage across the capacitor. To know these three graph, you have to write the 3 page code. you can understand how difficult it is for a converter or multi-level inverter type of thing. Now, now go to the this MATLAB plus using Simulink. Here we write a simple, small 6-7 line code that is only for getting the values. That is only for getting the value input voltage, that inductors value, that registers value, that capacitor value. Only those things we have to provide, and rest of the thing we will make in Simulink model. Rest of the thing we will make in the Simulink model, and we will get I1, I2, VC in the workspace, means in the time stamping in the format of Excel format with time stamping. All the voltage and current parameter. Not only that, we can also see the all three figure in the single scope. So it is like this. I'll show you. The same thing you will get here. For Simulink, we will do several exercise, but for MATLAB, I'll show you the code and everything in the MATLAB block. My MATLAB window is visible to you, or I think it is not visible to you. Just check. Just let me change the window. Just give me a second. MATLAB 2030. Okay. Now it is coming. My MATLAB window is coming now. Just check.
Yes, sir.
Okay. Fine. 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 So here I'll show you. I'll show you. Just give me a second so that I can open my file. Just give me a second. Just give me a second. This open. Let me open this code. Now, is it visible? Is it visible or
Yes, sir.
not?
Yes, sir. Visible.
You can see the only MATLAB code example way one case one. Is it visible?
Yes, sir. The MATLAB screen is visible, and the code in the command window is also visible.
Okay, okay. No, see, I have opened the file that is editor. Editor C user. Is it visible? I don't think so. Let me change the screen. Just give me a second. Just give me a second. Now I think it is visible. Only MATLAB code example one case one. Can you see? My editor window is visible to you.
Sir, RLC.m वाली file visible है.
हाँ RLC वाली.
हाँ sir, it is
देखो
visible.
मैंने अभी ये इसमें ढेर सारा सिलेक्शन किया है. I made
हाँ
this
sir. Yes
selected
sir.
visible.
Yes sir.
So what I
Visible.
did, I just wrote the same code here, that the value of various parameter. Then I have made the program for that. I have given the sample time. It is 0.0001, and I did the iteration for various values of n. Then for figure I have written this program, and for getting plot I have used the plot function. Then I have given the grid, then y level, title, each and everything I have given. I have written this much code to generate the response for RLC circuit. Right? I'll show you the just give me a second. I'll show you the entire screen so that you have a better picture. Now you see, to getting the to getting this, I have written this code. I'll show you. This, right? The same code I have written in the form of M file. This, then T is equal to this, then iteration and all. Then for showing the graph, I have used this. All this code I have written, all this code I have written to get these results. Now I am going to run my code. This is my editor window. What the hell is this, yaar? People are keep on coming. So I just press this run button. Now change folder. You see, I'll getting the same graph. I'll getting the same graph. This is the response of I1, I2, and VC. So in this way, you have to do the programming in .m, and for that, Rudra Pratap book is very famous book for .m programming. If you are interested to do those type of things, then you can use that book. Clear? Now I'll demonstrate you some small program so that you would have better understanding of this .m programming, right? For convenience, I have already written all these program so that you can see. For example, I wish to solve the quadratic expression. I am directly writing it in the command window just to save the time. Otherwise, you can make in the .m file format and just go to the editor and run. Anyway, there are these two ways. Now you know the function is ax square plus bx plus c. It is asking the value, enter coefficient a. Let us say it is 2. Just press the enter. Now it is asking enter coefficient b. Let us say it is 5. Now enter coefficient c. Let us say it is 3. Then enter. It would have a complex root, means 2x square plus 4bx plus 3. If you find the value of this root, it will give you the complex root, right? So that type of thing you can do. Here you can see what I wrote, that I am taking the variable ABC from the user, enter coefficient A, and I am reading it. Enter coefficient B, I am reading this. Enter coefficient C, I am reading this. Now the simple formula, that is what? B square minus 4AC. We know if B square minus 4AC is greater than 0, then two roots are this, and roots are x1 and x2. If it is equal to 0, then roots are equal, right? Then print complex root. If these are neither the real neither the real nor the equal, then it will print the complex root. It is not going to show you the value of roots. It will simply give you the stating that these roots are complex. Now I'll run this program again. Now it is asking uh, give the value of coefficient, right? Give the value of coefficient. I am giving the value of A is 1, B is 4, and C is, let us say, 2, right? So that my B square minus 4AC would be greater than 0. B square is 16, 4AC is 8. So it should give the real values of root. Now just press the enter. Just see the roots are minus 0.59 and minus 0.341. So our roots are equal. Now I'll run it one more time. Again it is asking give the values of coefficient A, B, C. Now I am going to give B square minus 4AC equal to 0. So that root will be come real and it would be minus B 2 by A. So B square minus 4AC has to be equal to 0. Let us say this value is 3 and B square is 9. 9. No. 3. Let us make it 3. So our B square is 9 and 4AC has to be equal to 9. 4AC has to be equal to 9. That means C must be equal to 3 by 4. Let us make this 3 by 4. Now B square is equal to 4AC. Just enter. Just see. These are equal root and the value of root is minus 0.50. You just see for a simple program, this print F, it is used for printing anything, and rest is if else statement. Very simple program I have written. Very simple program I have written. Now these small program you used to do in your I think signal and system one UG level course is there. There we used to do this, right? I have taken the I have taken the another program, that is multiplication of two matrices. Multiplication of two matrices. It is 2 by 2. Yes, someone raise the hand if you have any issue. I'll request to this Prince Shukla. Prince Shukla, if you have any issue, just tell me. I have allowed your mic. Prince Shukla, if you have any issue, you just unmute yourself and tell me. Otherwise, lower your hand. I think by mistake he raised his hand. Prince Shukla, Prince Shukla, Shivansh. Okay. If you do not have any issue, just raise your hand by mistake. Then choice is yours. Now, let us take some more example. This series RLC circuit. Series RLC circuit. The CLC and CLR, it is used for clearing the data. whatever you have written in the command window, each and everything get vanishes, and the starting point would be which you have displayed. Now put the value of resistance. Let us say it is 2 ohm. Now it will ask the value of inductance in Henry, 0.001. That is 1 millihenry. It will ask the capacitance. Let us say it is point zero 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 two. That is 20 microfarad. Now frequency, it is 50 hertz. It will give you the impedance. How it is giving you the impedance? It is simple. Under root of R square minus omega L minus XL minus XC square. Right? Under root of R square plus XL minus XC square, where XL is equal to 2 pi FL and XC is equal to 1 upon 2 FC. These simple calculations are used. And see how beautifully it is giving the value of these impedances and all. Here, now come to the power factor calculation. Power factor calculation. What is the real, which I was discussing that this when we take the branch and when we take the load, right? When we know the power, then we use the load, right? So real power, let us say 100 watt. Apparent power, let us say 500 VA. So power factor is 0.2. How we calculated? Active power is VI cos phi. Active power is VI cos phi. And if you look at the programming, it is very simple. Just clear the screen. Ask the user for the power. Input is whatever you have written in the inverted comma, that would become the your this display, you can say, right? So you can see after colon we have provided the space. Now it will ask to user give the value, and whatever the value you will give, it will display here. It will display here. Similarly for VA, and then power factor is PYS, that is active power divided by volt ampere. Active power divided by volt ampere, and then it will display the value of power factor. Then it will display the value of power factor, and you have to also give the values of means after decimal places. As I have given the value zero point 0.3, that means it will give the value after up to 3 decimal places to 200. Now if I make it 5, it will give you up to value of 5. Very simple program I have included in this, so that you can do it at your end. Now let us check how many of you are doing. Yes, just raise your hand. Raise your hand. How many of you are doing? 1, 2, only 3. Okay. At least it will give me the idea how many of you are attract. Okay, 9, 8, fine, fine, fine. 10, 11, 13, 14. Let us check this. Let us check how many of you are doing. Only 15. Okay, 15. So total 15 hands are raised. Total 15 hand are raised. Okay, fine. Just give me a second. Let me check how many participants are there. Fine. At present, we have 131 attendee. I was just checking. Then they will come and ask for feedback. Eh? They will come and ask for feedback. Fine. So again, go to the this place. Take some more example. Now I'll do the Fourier series of square wave. Control C, then go here, just put just C. We will this the see that that was the previous one. Just give me just a second. Here it is. Just give me a second. This. So it is the square wave. You can see square wave in the sense means it is not no longer the sinusoidal wave. It is no longer the sinusoidal wave. So if I give the Fourier series, it will constitute the actual wave in this form for a cycle. For a cycle, just see it will plot. It will plot the square wave using Fourier series at x side. I mean the horizontal. It will display the time. At vertical, it will display the amplitude. And how it is calculating its amplitude? Its amplitude is 1 by n times the fundamental. 1 by n times the fundamental. It will ask the frequency and everything, and depending upon that, it will display the Fourier series. Using Fourier series, it will constitute the is its actual wave, right? Now let us do some example of the DC motor. First, see, and don't expect that I am going to tell you what is the formula for speed. See, the separately excited motor, it is V is equal to E plus IARA, it is always, and E is equal to K phi omega S. So, omega we can find out if we know the voltage, current, and the resistance of the machine. So, K phi is equal come out to be V minus IARA, then divided by the value of K, it will give you the speed omega. Now, let us do this. It will ask you the supply voltage. Let us say my supply voltage, DC supply voltage is 200 volt. It will ask you the armature current. Let us say my armature current is 4 ampere. It will ask you the armature resistance. Let us say my armature resistance is 0.02. 0.02. Now motor constant you have to give. You have to give the motor constant. The motor constant is, let us say, 0.97. Enter. The motor speed is come out to be 206.10 RPM. 206.10 RPM. Very simple program. It will ask the input supply voltage and this V colon space. If you leave space blank after the colon, it will ask the user to give the input. Alright. So we have taken the three variable, no, sorry, four variable V, IA, RA, and the K5 from the user, and applied the formula of speed V minus IARA divided by KPH here. Then print the value of this speed. Again, up to two places of decimal. You can see it is 10.10, right? जितने भी प्लेस तक आप दोगे, it will give you the value. For example, now let us make this 5. Let us make this 5. Now if I run this program, it will give you the value up to 5 decimal place. The value of voltage is 200. The value of armature current is 2 ampere. The value of armature resistance is 0.02. The value of K5 is 0.97. You can see it is given 0.1443. That means up to fifth place of decimal. So this is how you can program the do the programming in the this uh, .n, right? Let us take some more example. Already I have covered one very good example. This is matrix. Okay, let us take this. You can do this program using the switch function. I'll show you. Control C. Then go here. Go here. Now it will ask the matrix A. First, I'll tell you 1 space 2 space 3 colon 4 space 5 space 6 colon 7 space 8 space 9. Then now it is asking matrix B. Let us say it is 2 3 2 3 4 colon 5 6 7 colon 8 9 0. Enter. Now it is asking the choice from the user what you wish to do: addition, subtraction, multiplication, or transpose of matrix A. What you wish to do? Let us say I have pressed the button 2. Now it will subtract matrix B from matrix A. You will get the result. Now I'll again let me small change in the program. Rather than clearing the screen, I am not clearing the screen so that we can see the calculation. Control C. I have written all this program prior to this. Reason is I don't want to waste the time in typing. Now I have clear without clearing the screen. I have written the entire program. Now I am giving the same matrix. I am giving the same matrix here. Control V. And I should remove this matrix इसको control X. Now enter again control V and should delete this and enter. Now and again it is asking ये मोबाइल में यार ये someone using my mobile number to verify something. This is not. This should not be done. Dhruvi, Dhruvi, are you there?
Yes, sir.
ध्रुवी और यार ये बहुत सारे कोड आ रहे हैं ओटीपी वेरिफिकेशन के मोबाइल में.
किस लिए?
पता नहीं. आकाश एमएक्स मतलब someone is using at different site my mobile number. That is why this is coming, I think.
सर आप सेशन पे कंटिन्यू करिए, मैं कुछ आगरे सर से बात करती हूँ एक बार.
ये जो है ना, एक सेकंड. वो अननेसेसरी पार्टिसिपेंट ही बदमाशी मुझे लग रहा है कर रहे हैं. Okay, now just see. Let me close this. Just give me a second. Actually, some disturbance came from some other side. Let me close all this. No, no, no. Okay, fine. Fine. Okay. Just enter the choice. Like I'll enter 3. It is, you can see I have entered the choice for multiplication. Now matrix A is multiplied by matrix B. Each element is multiplied and you will get the answer to. So this type of things can be done using the .m file, and all this thing can be written here. Script. Here you can write the same thing. You will get control B. Sorry, let me take from the file. Should take it from here. Copy and then यार ये somebody is doing something.
सर
हाँ,
ओटीपी
ये वेब
बॉम्बार्डिंग हुई होगी, किसी ने कहीं एक जगह से कर दिया है, तो आप अभी फोन साइलेंट कर दो, वो अपने आप रुक जाएगा 10-15 मिनट में।
ये जो है ना, मतलब डिफरेंट डिफरेंट साइड से आ रहा है जो
हाँ
भी।
हाँ, वो मल्टीपल साइड से ही आता है फिर।
हाँ, ये तो मतलब एक्चुअली मेरे अकाउंट्स वगैरह भी है ना, तो थोड़ा सा वो कुकू टीवी और डिस्ट्रिक्ट ऐप, वो जो सब मतलब वेबसाइट वगैरह नहीं होती हैं पेड
हम्म।
वाली, उन्हीं से आ रहा है। तो कहीं ऐसा ना हो पता चला मैं लेक्चर लेता रहूं, कोई मेरा अकाउंट ही ले ले।
नहीं
राइट।
नहीं सर, आप फोन साइलेंट कर दीजिए, वो अपने आप ठीक हो जाएगा अभी।
Now I'll put it in airplane mode, right? Okay. So I'll see what I can do. This now when you run this, it will ask to save this, right? I am saving this in the MATLAB. Let us say code underscore m. I have saved this. Now it will change the folder. It will ask to change the folder. I have changed. You just see when I run that code m, single .m file name is to be run. The code m file is run, and now it is asking the matrix. If you give any matrix, A is equal to, I am giving like 1, 2, 3, semicolon, 4, 5, 6, semicolon, 6, 7, 8, bracket close, enter. Oh, 6, 7, 8, ये स्पेस नहीं दिया है, कंट्रोल V, give the give the space 6, 7 and 8. Now it will take. Again मैं एक डिजिट खाली बदल दे रहा हूँ इसकी, 4, 7 and it is 9, 8, 7. Delete. Now it will ask the choice. The same procedure it will follow. Let us say I'll doing the transpose of this. It will give that transpose within a second. Within a second, it will give. Right. So in this way, we will do the .m programming. In this way, we will do the .m programming. Now we will do the RLC circuit. We will do this RLC circuit in Simulink. Right. In Simulink. Can we change the mode? Means I wish any participant can share his or her screen, and I'll tell you from here so that active participation can be seen in this. For Simulink, you will do and I will tell here how to do, or I'll do at my end and share my screen. It is totally up to you how much you wish to involve. Anyone who wish to do the simulation, the person is meeting us, we can verify that. Yes, anyone? Yes, Arun. Arun, you wish to do? Now you
Yeah.
can unmute
Mhm.
screen.
Hello. I'm audible, sir.
Ah, you are very much audible. It
Yeah.
would be great if you share your screen.
Yeah. Not yet.
Then
I
I
have
will
done.
tell you.
I just, sir. I just want to link that application link as well as that documents file. So I will do the practical ones myself.
Okay,
Yeah.
you want the documentation so that you can do at your end after the workshop, huh?
Yes. Yes. Yes, sir. Actually, I'm in office
So,
also. So currently, I can't do like that
so
practical.
you
So
just
after finishing my work, I will do it at home.
it's great.
Yeah.
We we have already webcast this link,
Yeah.
right? So you can check on the YouTube itself.
Yeah.
And if see, actually, this is my experience that the student always asking for, sir, give me some PPT, give me study material. Once you got those material, you will never touch it, right? So what I wish, you just go through the video, check it there. Each and everything what I am showing here, that is available on the that domain. And if the link is not available, I'll show you. I'll send you the recording of this entire meeting, entire session in the WhatsApp group. So from there you can do.
Yeah.
What
Sure,
I
sir.
wish right now, if someone is having MATLAB with Simulink, I wish कि आप उसको चला करके आप मतलब you just run your MATLAB and show me the screen. I'll tell you how to do. Otherwise, I am going to make it here itself. So it is totally up to you. Anyone interested? If anyone is interested, just tell me. Okay, then who is this? I mean, एक तो ये Shiva. I have giving the permission to you. You can unmute yourself and tell me if you wish to
Yes, sir.
run. Yes, you wish to run this Simulink model.
Yes, sir.
So it would be great. Reason why I am asking na, because if I start now within 5 minutes it is over. I'll make you guys to understand which are the block to be taken and why it should be taken and from where it should be taken. That is the purpose of this hands-on workshop. It is not a simple type of workshop. So you just share your screen.
Sir, please allow permission to share.
Okay, just give me a second. Just check. Now you are able to share your screen. I am stopping. Just check. Just check.
Sir, I have shared screen. Is it
Ah,
visible?
yes, you have shared. Good. Now just click the library browser. Just click the library browser. Everyone can see his screen. कोई भी एक unmute होकर के बता दो. Anyone
Yes,
just
sir.
Yes, sir.
unmute.
Yes,
Okay,
sir.
Yes.
I
good,
can see, sir.
good, good,
Yes,
good, good,
sir.
good, good.
Yes, sir.
Just बच्चा just click the library browser.
Sir, I think I have to restart this page because not
Huh?
supporting currently.
Any problem? Okay, leave it. I am going to share. Just don't worry. Just don't worry, I am going to share. Okay, सबसे पहले first of all what we will do, this close this. Now we will open the Simulink model. Here is the Simulink model. Now what we have to do, we need one this AC source, we need one resistance, we need one inductance, we need one capacitor. Just click this and go to the sim power system. I suggest you guys do at your end. Anand Patel Saab, let me unmute yourself. So just go to the sim power system, go to the element. Here you can have this series RLC load and series RLC branch. Just check the PPT here so that we can have the same parameter. Just check what are the parameter we have taken. This here it was step input, means we have to take the we have to take the DC input. So we will go to the our library and take the element. Take the element means the series RLC. Okay, fine. Now take the sources, electrical sources. Take the DC voltage sources. Right? Now I have all the power circuit, but how to measure the voltage and current? For that we must have the voltage measurement, we must have the current measurement. Now you got the measurement, means you got the probe of multimeter. Then where you are going to display this? You should have the scope. Take it, sync, scope, take this scope. Then you also wish to add this data on the workspace. At the same time, you also wish to display this. Now, let us connect all of them. Let us connect. I hope my screen is visible to all of you.
Yes, sir.
Yes, sir.
Well,
Yes, sir.
this is your DC. Now, this is your series RLC branch. You just right click and shift, you will get the copy of this. Right, you will get the copy of this. Now make it, just see the circuit, what is there. There is one RL in series, RS, and then mutual. So we will take it 3 inductor and 2 resistor and 1 capacitor. This resistance value is RP. RP is how much? Uh, 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 LP, LS. RP is 1, RS is 2. Okay, fine. Make it resistance. Okay. Make this resistance of value 2. Then make it inductor L. Also make one inductor here, and the value of this LP and LS is 0.1 and 0.2. 0.1 and 0.2. This is 0.1. Okay. This is point 2. Okay. Now connect. Now connect. When you do yourself, na, then you will come to know the real problem. This is the capacitor. Okay. I will give the values afterwards, and then one resistance is also there. Then one resistance is also there. You just do the control R, it will automatically rotate. Connect this, connect this, connect this. And then still people are keep on coming. And what is the value of inductance? This capacitor is 1 microfarad and this Mi is 0.1 Henry. This is 0.1 Henry. Connect this 0.1 Henry, 0.1 Henry, 0.1 Henry. Then check the values. This is how much? 1 microfarad. 1 e to the power minus 6. इसमें 10 to the power को क्या लिखते हो? E to the power minus 6. It is 1 microfarad. 1 into 10 to the power minus 6. And the value of this R1 is how much? R1 is 1 ohm. This is 1 ohm. Absolutely fine. This inductor is 0.2. Absolutely fine. This is 2. This is 1. Now take the value of this is 10 volt as it is set. It is equal to 10 volt step input, right? 10 volt step input. Step input means after some time it will give that value. So that also we can take it from there, but at present I am taking this because for that you have to take the voltage source, dependent voltage source that you have to take. But anyhow, no problem at all. Now what we have to measure? We have to measure these two current, I1, I2, I1, I2 and capacitor voltage. So for that, just take the voltage here and we will measure from here. We will measure from here to here. This is your capacitor voltage. Now I1 and I2 has to be measured. So I1 and I2 has to be measured. Just delete this, take current here. Current is entering here, going outside, and it is giving you the display. It will give you the display. अभी कनेक्ट नहीं करेंगे. We will connect after that. हाँ अभी connect करेंगे. We will do. Now the second current, you should take it from here. If you do at your end and any problem is coming, please tell. We will enjoy. So now the problem is what's the problem? Problem is we have three signal and only one axis. What we can do? Go to here and make these number of axis.
Hello, sir.
Yes.
Can you show me the value once again because my MATLAB was
Pardon, beta. Yes. What are you saying? My voice is coming. Aniket, what are you saying? Just unmute yourself. ये अनूप कुमार खनूजिया is several time he is coming.
सर ये बीच बीच में डिस्कनेक्ट हो रहा है, तो जिसे कैसे वो कर रहे हैं सर, वहां टर्मिनेट हो रहा है।
अच्छा, somebody is doing. Let me change the. Just give me Anup. Just give me a second. Now Anup, I hope नहीं होगा अब. Okay. So yes, Aniket, if you have any problem, Aniket, I am unmuting you. Just give me. Now you can unmute yourself and tell me what you are asking, Aniket. I don't think so. He is having any problem. Leave him. Okay, now I'll make it 3 axes. So you can see we have 3 axes. We will connect I1 here. We will connect I2 here. We will connect voltage here. We can also take it to the workspace. This would be go as I1. This is sim out 2. This is sim out 3. Right. We can also have the display. We can also have this display. It will tell you the value during the running simulation, and in the last it. Now do you think this simulation will run? This simulation will not run. I'll show you. I just press the run button. It will show the error. Oh my god, so many error. So many error. It looks like we have made a very useless simulation, but it is not the case. What you have to do, you just go to the block library, go to the sim power system, add the very important block power GUI. Basically this power GUI tell various parameters which are to be used in the simulation. Sample time, solver, zero crossing. There are so many things needs to be clarified. 10 seconds, just open the window and check what exactly is coming. Just check what exactly is coming. It is coming like this. It is coming like this. Now, what could be done? Just a proper solver. Take OD15S and now make it discrete. Use the discrete with timestamp backward Euler case. Let us run this and see. Is there is any change? Now see, everything was same, but the results are now different. The results are now different. Just see that capacitor, the first, the first is your current. First is your current. It looks like कुछ आ ही नहीं रहा. Nothing is coming in the simulation. Nothing is coming in the simulation. What we did, just check the history. We have restricted ourselves in the last 5,000 points. So now let us run it once again and just check the simulation. Just check the simulation. Just see the result. This is your response. This is your transient response. Here you can see the value of the capacitor voltage. The value of the capacitor voltage is come out to be this. That is -1, and that too is oscillating. That too is oscillating. That means we have connected this wrong direction. Just change the polarity. Just change the polarity. It should be like this. Means this plate is positive and this plate is negative. This plate is negative. Right? And also let me check the parameter. 1 microfarad, 0.11, 2, 1.2 Henry, and this. This is 0.2, 0.2. This is 0.1, and this is 0.1. This is 1. This is 2. This is the problem. It is not 2. It is, just check. Just check the value. LP, LS 0.1, 0.2, 121, 121, 1. This is 2. This is 1. This is 0.1, 0.2, and this is 0.1. You can see the effect of these. You can see at initial your capacitor was uncharged. Your capacitor was uncharged and inductor is not allowing to flow the current. So the current is flowing through this. And one thing we can also do one thing. Just give me a second. Go here and let us make it fixed step with OD1, right? And see how the response is changed. How the response is changed. Now see, this is this is you just see there is a huge oscillation in the beginning, but under steady state I2 is almost 0. Sorry, I1 is almost 4 point I2. It is equal to 0.0015 somewhere around here. and this voltage level is, capacitor voltage is 0, not 0 exactly, some 0.1 0.2 voltage is coming. Just give me a second, just give me a second. Look at this, it is 7 into 10 to the power minus 4 is coming, right? Proper calculation has to be done, but you can understand the fundamentals, and I'll show you one thing. Let us make it R so that exact picture you can see. Circuit is not the problem, the values are the problem. Let us make all resistive, right? Now directly you can see the response will be straightforward. There is no oscillation or something like that. You just see the values across the voltage is minus zero point 0.3, and all throughout it is fixed. All throughout it is fixed. It is negative. Why it is negative? Because the current would flow like this. So this voltage is in opposite direction. But in previous case, the capacitor was showing negative. Why? Because there was presence of inductor. So because of presence of inductor, the capacitor voltage may get change, right? Polarity may get change because of presence of inductor. Now you will see. Look at this. It is now positive, somewhere around 3 volt, somewhere around 3 volt, and this current is almost zero, almost zero. Means there is no current flowing through this. Why it is so? Because if you measure this voltage, if you measure this voltage, this voltage, the capacitor will charge up to this voltage. Just see how much it is, 1, how much it is, 1, how much it is, 1. So this is 10 divided by 3. So somewhere around 3.33. This much current is flowing. Yani this voltage is 1 multiplied by 3, 1 multiplied by 3.33. So this voltage is 3.33, and when the capacitor is charged up to this voltage, it will not allow to flow any current. Once there is no current, this value is 0. That is shown in the waveform. You can see I2 current is 0, and this capacitor voltage is up to 3.33. That you can see here. Just see, right? 3.33, 5 say come, means 10 divided by 3. The value of this is 10 divided by 3. That you can see in the display. That you can see in the display. 3.33. Right? So this is the way how we do the simulation in the MATLAB using the Simulink. And one thing more I would like to, halaki that is not possible in this case FFT analysis, that we will show in tomorrow classes. Here we can see the total harmonic distortion and all. But since it is GC, so that is not an discussion of this. That we will see in tomorrow class. Right? So if I see a schedule, let me check whether I have cover each and everything, or okay, single phase and 3-phase circuit modeling. See, single phase modeling we have seen. This 3-phase circuit modeling we will see when we will see this multi-level inverter, 3-phase multi-level inverter. Then we will cover this. Right? So for today's session, if you have any doubt, you can ask me now. Starting from morning 12 o'clock to up to 3. If you have any doubt, you can ask me. If you have any doubt, you can ask me. Or no doubt you have. Yes, my voice is coming or not? यह सारे पार्टिसिपेंट हमारे सो गए. हाँ, yes. Nikhil Jain, you raise your hand. I am unmuting yourself. Just give me a second. Yes, Nikhil. Nikhil Jain,
Hello, sir.
you have raised your hand. You have any doubt?
No, sir, that I have used the 2025 version of MATLAB. From previous year,
Ah,
I was using.
yes,
I
yes.
am using the 2025 version of MATLAB.
Okay.
Is there any problem using that?
No, not at all. Not at all. Even if you use 2025, 26 or the older version, there is absolutely not a problem. The only thing is that you might find that rather than having this sim power system toolbox, you may have sim escape. Directly you can do the system based modeling there. Only the difference is that nothing else.
Okay, sir. Thanks.
Yes, someone else raise the hand. We have 126 participants at present. My PhD research scholar Anup Kumar Khanuja is trying to join, but unfortunately his network is not supporting. That I can see. So still we have 3 minutes. If you have any doubt, you can ask me. Do you have any doubt? Hello. Hello. Yes, Kushagra, Dhruvi, my voice is coming, and if no one is having any doubt, then I am displaying my contact details. You can connect me in case not now, after some time you feel any problem or any type of doubt, you can ask me without any hesitation. This is my screen. If you do not have any doubt, I am so happy that I taught you so well. You are not having any doubt, and this is the channel which you can subscribe or watch this live recording of the second session. Although the first one is removed by the Facebook, YouTube itself, and my LinkedIn as well as WhatsApp number I have shared. In case if you wish to connect me, you can scan it, or you have any type of doubt, you can. Yes, Ruby, are you there? Dhruvi Singh is there. Okay. Dhruvi, I have unmuted you. So you can now unmute at your end.
Yes, sir.
and share the feedback. We are absolutely on time at 3:09,
Yes,
and if participants are not having any doubt, so we can wind up.
yes. Thank you so much, sir, for such enlightening and inspiring sessions. Your ability to seamlessly blend theoretical concepts with practical application has made today's learning experience both engaging and impactful. The depth of knowledge, clarity of explanation, and real world insights that you have shared has not only enhanced our understanding of MATLAB and Simulink, but also motivated us to explore these tools further in our academic journeys. With this, we come to the end of day one of MATLAB and Simulink workshop organized as part of the PLS Day celebrations. I request all the participants to fill out the feedback form of session 2 that is being shared in the chat. Please note that the attendance for the workshop will be recorded through the feedback forms only, and submission of the form is mandatory for certificate eligibility. We look forward for your participation tomorrow for another exciting day of learning and hands-on experience. Ronak,
Yes,